Imagine you're pushing a box, sweating, but it doesn't budge. Frustrating, right? But guess what? In physics, no movement means no work. Shocking, isn't it? Let's dive into work, power, energy, the trio that governs almost everything around us. From the energy fueling a roller coaster to the power of a wind turbine spinning. These concepts connect all the dots of how the universe operates. Power, it's all about how fast you do the work. Think of a sprinter. Explosive speed means high power output. And energy, that's the ultimate space shifter, turning from heat to light, motion to sound. Stick around because by the end of this chapter, you will see the world in a whole new light. Work, power, energy, it's not just physics, it's life in action. But students, before we start, don't forget to like, share and subscribe to our channel. Let's learn together. Hi everyone. Today we are going to begin with a new chapter of physics, that is energy, work and power. So far we have talked about physical quantities and measurement techniques. We have talked about motion and we have also discussed about forces. Now we are going to take another aspect, that is about energy. Alright, so without wasting any time, let's dive into this. What are we going to discuss in this unit of energy, work and power? So put down the heading without wasting any time. Energy, work and power. Alright, so the first thing that we have to talk about is energy, right? So energy in general, you do understand, is basically the capacity or the ability to do work. So when you say that you are highly energetic right now, that means you are willing to do a lot of work. If you have lesser energy, then you don't have the tendency to do further work, isn't it? So that is how you relate with energy. Still, from physics point of view, let's understand what exactly that means. So one thing, like, this is much of a theoretical chapter, but the understanding of these topics is very important for doing the numericals further as well. So be very careful. You need to understand the core concept so that it's going to help you to solve numericals of further chapters as well. So keep that in mind. So energy is the capacity to do work. The SI unit of energy is joule, and we will study energy in two parts: energy stored and energy transfer. Understand? So when you say energy, that is the capacity to do work, that's all right. Its SI unit is joule. We'll understand what exactly that means later. But we will also bifurcate this study of energy in two parts. One will be energy stored in an object. So for example, when you charge your phone, you say that energy is stored in the battery, right? So that is energy stored. On the contrary, when you're charging the phone, let's say, when you're charging your computer, whatever it is, then you are transferring energy from the supply, that is the mains that you have, the electrical energy, to the battery in the form of chemical energy. So these terms you might be knowing, that what is chemical energy, what is electrical energy. You can have a decent understanding of these topics. But what I wish to tell you is that you will talk about energy in two aspects. First is energy stored and the other is energy transferred. All right. So that's about energy, the basic thing. Next, the various forms of energy. So let's quickly do the vocabulary part here, that what all are we going to talk about in this particular unit. So the first thing is potential energy. Potential word means again, ability to do something, right? So potential energy means the stored energy. How much energy is stored in an object or a system. All right. So potential energy, we will have further bifurcation of it in the form of chemical potential energy. For example, the cell or battery of your mobile phone, that's like chemical potential energy. Second is elastic or strain energy. What do you mean by that? So let's say there is a spring. You can understand what a spring is. I have already talked about that in the previous classes. The spring, when it is relaxed, it doesn't look like it has energy. But when you compress it, it feels as if it has some stored energy, isn't it? So that we will discuss, but right now just to give you an idea, that's elastic energy for you. Then is gravitational potential energy. What is it? Gravitational potential energy. You do understand what is gravity. So we all are, part of the Earth's gravitational field. We are in the Earth's gravitational field. So we all possess energy because of that. So for example, this pen, this has potential energy because you can clearly feel it, that when you drop it, it automatically falls. So it feels as if it has energy. Imagine if this would have been in space where there was no gravity, let's say in interstellar space. When I leave this pen here in space, it will stay here. It won't drop. So then this energy won't be there. So what does that mean? That this energy is existing in the pen when it is in the field of gravity or Earth. Alright. Next is electrostatic potential energy, something related with charges. I won't go into the details right now, but just to give you an idea, somewhat related with charges. So electro word is basically related with charge. Keep that in mind. So this is one set of potential energies, like these are the bifurcation of potential energy that we are going to majorly discuss. Next is kinetic energy. So this is another form of energy that is basically kinetic, kinesis. The word is related with motion. So kinetic energy is the energy related with motion, of course. Next is electrical energy. Okay. So when I said that, the supply, the current, that is the energy we are taking out and then storing in the battery. So that's electrical energy for you when charges are in motion, when there is current. So even if you don't know what is current, at least you have heard of it in general terms. So that's related with electrical energy. Next is thermal energy. All right. So thermal energy is related with heat, is related with temperature, is related with, hotness of any object. That also, makes that particular object possess some energy. Don't worry, we will talk about all these. You should have a good understanding of all these topics. Okay. Electromagnetic sound and other waves. So then there are, energy in the form of wave. There is energy in the form of waves. So for example, you come across the terms light energy, sound energy. If I'm talking, obviously there is some energy, there is some vibration that's going on. So that is sound energy for you. And light is, of course, is a form of energy. That is how you have talked about, in context of light. You've always called it as a source of energy, as a form of energy. And next is nuclear energy. Right, nuclear energy, somewhat related with nucleus. You understand what a nucleus is. Nucleus is basically the core of any atom where the protons and neutrons exist. Even that has, some sort of energy we will discuss. You might have heard of the terms like nuclear bombs, atom bombs, stuff like that. So they are all related with nuclear energy. So now you have an idea. This is what we are going to discuss. This is what we are going to talk about, the various forms of energy. Please grab a screenshot of this and you can copy this down later, because any which way, one on one, we are going to talk about one by one. We are going to talk about all these energies in detail. I will wait. You grab a screenshot, then we move forward. All right. So now if that is done, first, let's talk about potential energy. I will read it out to you. Today, we are discussing a lot of theory. This is very different from what we have been doing so far, where in motion or forces, we were majorly talking about the various situational numericals. Here, first, we have to understand the theory part. So, it is the energy stored in a system. Of course, potential energy is a term associated with stored energy. This form of energy is due to the state, shape or position of the system. So as I said, in case of spring, it was like the state or the shape that made us store energy. In case of this pen, it is the position of this pen in the gravitational field of Earth which is making it store energy, right? There are different types of potential energy. Each of these type of potential energy can be converted into the other forms of energy. So that we have already talked about. that we will talk about, transfer of energy. That means, some form of energy can be converted to another form of energy. For example, this pen released here and it falls. So obviously, you are able to convert the potential energy into the kinetic energy, right? Or let's say if you have the spring compressed and you release it, then again it relaxes. So potential energy goes into the form of kinetic energy of the spring particles. All right. So that's about potential energy. You can write a one-line definition. It's always a good habit to keep writing while you're learning. That obviously gives you a better, way of retaining things. I always believe in that. So please make sure you have your notebook with you and you keep writing the important stuff. All right. So next, chemical energy. So again, you have an idea of what it is, but still just the basic definition. Chemical potential energy is the energy stored in a substance due to the position of the atoms or electrons. Right, somewhat related with chemistry. Isn't that what we are expecting? Some chemical formula, some kind of chemical reaction. You have heard of, various types of batteries. For example, lithium ion batteries, right? Or even sodium batteries these days. So all these batteries have some, chemistry in them that makes them store the energy. That means they will be based on some chemical reaction that would release energy, isn't it? So that is a chemical reaction that will release energy. Majorly when I talk about batteries, then it converts into electrical energy, motion of electrons, if you understand. Or it can be like the food that you eat. What do you think about that? So the food that you eat is also in a way chemical energy, because you take in food and that energy is stored in the form of fat, muscle, whatever you can call it, and then what you do is you do some work and you consume that energy, right? It can be some kind of chemical bomb where you ultimately have a chemical reaction that explodes, and a lot of chemical energy goes in the form of heat. So you do understand what chemical energy is. Still you should know the basic definition. In the substance that can be released when chemical reaction takes place. The food that we eat, fossil fuels, battery, all these contain chemical potential energy. Fossil fuels is also something that you do understand. We are majorly relying on fossil fuels so far, but then now things are changing. But yes, fossil fuels like is a way of storing energy that is ultimately taken from the sun. So plants, algae, all those things have stored the energy of the sun. That is what even plants do. They take the sun's energy, right? You have talked about all this maybe in the previous classes, photosynthesis and all those things, where sun's light energy is converted into the chemical energy that goes into the plants, and then it is like going into different forms. So whatever it is, you do understand what chemical energy is now. I can wait and then we move forward. All right. Next is elastic strain energy. I have already talked about it. Is the energy stored in a body due to its elastic deformation. A spring or a rubber band possesses elastic potential energy when it is compressed or stretched. That is the thing. Like anything has its normal shape and size, where it is, it will acquire that. When it is left alone, no disturbance is there. So for example, if you you have a spring, you keep it on the table, what length it will acquire is its natural length. Now if you compress it or you elongate it, then it will store some kind of energy, right? Can you not think about it? So when you're let's say extending it or compressing it, you are consuming your food energy, right? You're consuming your own energy to do that. So your energy is going in the form of potential energy, in the form of elastic potential energy or the strain energy, right? So that is what this person is also showing. Like it takes effort to stretch that rubber band. So that means what? Your energy is being converted into the elastic potential energy. All right, make a note of it, then we move forward. So I am just briefing things to you. Maybe it is not it is not going to deserve a lot of time. So what we are doing is we are briefly giving an overview of these terms so that quickly we can, do on the or go on the application part of it. So maybe, in general terms, these things, just that, I just wish to cross check that, all these things are known. So gravitational potential energy is the energy stored in a body due to its height from the ground when an object is raised against the force of gravity. So you do understand, even in lifting a block from ground, you will need energy, right? So you will consume your energy and that block will gain energy. What sort of energy it is gaining? It is gaining gravitational potential energy. That's because when you're picking it up, you are doing work, you are spending your energy and giving it to the block in the form of gravitational potential energy. Keep that in mind. Now think about it. Let's say you pick this block from here to here, let's say. So the energy, we also call it the gravitational potential energy, so we call it as GPE. This GPE, or the potential energy, we can also write it as EP, right, has to be proportional to the mass. Think about it, more mass will possess more energy because you will have to do more work, it will have more energy, right, because it has more weight. Then it is also proportional to the gravitational field strength. If you know about it, in the previous chapter we have talked about it, that what is the difference between weight and mass. So weight is basically the force, right, that the gravity is applying. So that depends on the gravitational field strength of that particular planet. So you do understand that for Earth, the value of gravity is 9.8 Newton per kilogram, or approximately 10. So Earth gives a force of 10 Newton approximately for every kilogram. That might be different for different planets. So the gravitational potential energy that particular object will possess will also depend on the type of planet. For example, Moon, where you do understand that the gravity is way weaker, like almost 1/6 of the Earth, the same mass will not possess the equal amount of potential energy if lifted on Moon. You do understand that, right? Then of course it is going to be proportional to the height. The more, the higher you take it, more work you will have to do, more energy it will store. So combining the three, that it's proportional to mass, gravity and height, the potential energy is mgh. The higher the object, greater is its gravitational potential energy. We do understand that. So potential energy, keep it in mind, the formula for it depends on three things: mass, value of gravity and the height that you rise. All right, so make a note of this and then we move forward. All right, so the next thing that I wish to talk about is electrostatic potential energy. Now two things, we have an entire unit to study this in detail, so don't worry if you don't get it entirely, because we have a dedicated unit, and then all the time you keep learning about all these things in your chemistry if you have chemistry with you, right? So the thing is that electrostatic potential energy is the energy stored in the electric fields of static charges. So think of it like this. Let's say there is a charge, we normally denote charge by Q, okay? So let's say there is a charge, it can be a positive charge, it can be a negative charge. If left alone, it will stay at its own position. Now imagine if I bring another charge, let's say Q1, close to this. I don't know, it can be like charge, it can be unlike charge, but there is a certainty, either it will go away or it will move towards. Depending on if the like charges are there, then they will repel, it will repel the other charge. If it is unlike, then it is going to attract. I hope you know that. Positive, positive repel, negative, negative repel, while positive, negative attract. So it is going to either move away or come close to the charge. That means when left alone, it will automatically move. So it will feel as if there is some energy stored, right? Because as soon as you leave it, it moves by itself. That's what you feel for this pen. So when you leave it, it moves by itself. It feels as if it has some energy, right? So that is what it means. You know, the electric fields of static charges. When one charge is brought in the field of another charge, that is when it starts acquiring electric potential energy. Now, what is the difference between electrical energy and electrostatic potential energy? So when you first keep it, that's potential, but as soon as you leave it, it starts moving, and then it can give energy to someone else. That is what is called as electrical energy. So that is what you call as current. So when charge flows, though I do understand that you might not know this completely, but still you should at least relate with this, that when charge flows, that's called current, right? So electrical energy is the energy of an electric charge due to its motion and position. It is used extensively in our everyday lives. I don't need to tell that to anyone. We all do understand that whatever energy we mostly consume is first in the form of electrical, and then we convert it into various forms. So electrical energy in this modern world is like that crucial that we cannot imagine a life without electrical energy, of course. All right, so the next thing is kinetic energy, right? So think of it like this. What about wind? Let's come up with an example of wind. Imagine there is a static air, okay, in your room. You don't feel there is some energy. But what if it's a wind blowing at a high speed? You do feel that there is an energy, right, in the air now. That's what kinetic energy is. Whenever any thing or object is in motion, it possesses energy, right? So imagine there's a car going at a very fast speed, at a very fast pace. You cannot get in front of it. You do understand that it has a lot of energy which it can transfer to you, which you don't want, obviously. Or a bullet. So when you fire a bullet, what energy sort of it is having? So you would say it's kinetic energy, right? So it is the energy possessed by any object due to its motion or by virtue of its motion. Faster the object moves, greater is its kinetic energy. We don't have a doubt about it. So one thing that you might doubt here, but I will prove that later, that kinetic energy we denote by Ke or Ek is proportional to mass. Heavier the object, more amount of motion it will have because more particles are moving. Secondly, it is proportional to v square. So that is something that you might wonder, but if you remember, momentum was mass into velocity, right? Momentum was mass into velocity. That was the amount of motion. Here kinetic energy is proportional to v square. So it's not directly proportional, but it's proportional to v square, and then the constant of proportionality, let's take it as half. So kinetic energy is half m v square. We will prove this maybe in a couple of classes, or maybe even today. Let's see if we will be able to get there, but maybe in the next couple of classes we should be able to derive that as well. But then the kinetic energy is half m v square is very important. So this is energy related with motion, while this is the amount of motion. This is the amount of motion. So obviously you would want to relate kinetic energy with momentum. How can we do that? So sometimes it's very important, this correlation between the two. So what I can do is I can use this expression first and write v is equals to p by m, isn't it? I can write velocity as momentum and mass, the ratio of the two quantities. Then kinetic energy is going to be, let me write it as Ek only. Kinetic energy is going to be what? Half m, and if I write p by m for v, then this becomes, kinetic energy becomes p square, and then 1 m and other m cancels out. So this is p square over 2m. Okay, keep this in mind as well, because you would want to do some qualitative analysis or some numerical where you would want to relate kinetic energy and momentum, or you can write momentum is equals to root 2 MEK. Okay, so this is another way of expressing kinetic energy in terms of the momentum of the object or the system. Please write it down, then we move forward. All right, the next thing is thermal energy, right? So thermal energy, let's understand this. Let's say you have two iron bars like this. One, you keep it in the refrigerator, and the other you keep it on a burner, right? They were identical in all regards, just that they were kept in different environments. So when brought again, what is the difference between the two? You might say one is hotter, the other is colder. That is how you perceive it. That is how you feel it, that one is colder, the other is hotter. But what exactly would be the difference in the molecular, at the molecular level? So the difference is that the one that was at the burner will have its constituent particles vigorously vibrating. So understand this. Even this, if this pen looks energy less to you, it does not have any kinetic energy, and let's say it is kept at the ground level, then it does not have any potential energy also. Then what? Still its molecules are very slightly vibrating, and you won't notice that because we can't observe at that level, but they would. So this energy that it is possessing is called its internal thermal energy or internal energy. Maybe you will be able to relate more with the gas. Can you imagine the air in your room? Even if there is no wind blowing, can you imagine the particles are continuously still moving? You can't see them, but they are. So they are possessing kinetic energy, they are possessing potential energy of some sort. So this energy that the constituent particles are possessing in total of that is called the internal thermal energy or the internal energy. So that is what I've written for you. It is the total sum of kinetic and potential energy of the constituent particles of any object or system. The particles of a hotter body possess more internal energy than those of a colder body. So that is why when you bring the two iron bars in contact, you would definitely expect energy flow from hotter one to the colder one. So I hope you are able to understand a bit of it, that what sort of energy is this, and I have given you a brief of mostly all the energy, maybe a couple is left, and then we will use them in 2-3 numericals to end today's class and give it a head start to learn things further. Alright, so electromagnetic sound and other waves. So you do understand, electromagnetic waves. So light, you might have called it an electromagnetic waves. It has somewhat, something to do with electric fields and magnetic fields. That is, something that you might have heard of. So, but my idea here is to tell you that, you don't only assume that light is an electromagnetic waves. You might have heard of the terms infrared waves, ultraviolet waves, maybe gamma rays or microwaves, radio waves. The microwave in your microwave is basically based on, the microwave. That is the wave, the electromagnetic wave. So what I wish to tell you is that that is also a form of energy in a way. So let's say the energy, the radiation that we are getting from the sun, it's not only visible light, it also has ultraviolet, it also has infrared. The major heating effect that we feel is because of the infrared, right? So these are a type of radiation that carry energy and are created when electric field is coupled with a magnetic field. Keep that in mind. Example, ultraviolet rays, visible light, infrared waves, etc. So these are all examples of radiation or radiation energy. Sound energy is another form of kinetic energy caused by the physical vibration of air particles of the molecules, right? And why only air particles? Sound can even travel in liquids, sound can even travel in gases, in solids. So everywhere where sound travels, they in a way, pass kinetic energy to the further particles. So that is also in a way some form of energy. So that is called the sound energy or the sound wave energy. So that is what is about electromagnetic sound and other waves, right? So you should be able to understand that this is another form of energy. You might not have thought about it, but now you think of light and sound also as a form of energy. All right. So the next is nuclear energy, and if you ever had heard of what happens on the sun, like what is the basic fuel of sun, what is keeping the sun going, and so the answer is nuclear fusion. Hydrogen and hydrogen combine and they become helium. This releases a lot of energy. It is, if I may call it like that, but it is a chemical reaction of the nucleus. So in normal chemical reaction only electrons interact, right? Atom interact. Here the nucleus combine or nucleus break. So you can imagine that this reaction is way more capable in releasing energy as compared to a chemical reaction. So these are based on nuclear reactions, which is mainly of two types. One is fission. So you might have heard of nuclear fuels like uranium, which are radioactive, which are unstable nucleus. So they go for fission. They are bigger nucleus. They break down. Don't worry, we have a particular unit where we will discuss all this in detail. I don't want to confuse you very much here, but just to give you an idea that whenever you talk about nuclear energy or nuclear reaction, they are of two types, fission and fusion. Fission is breaking of a nucleus, fusion is combining of nucleus, right? Fusion. All these are capable of releasing tremendous amount of energy. That is why now many countries are relying on nuclear fuel to produce electricity or converting nuclear energy into electricity, because they have a high capacity or potential to give energy, right? So it can be found in the nuclei of atoms of radioactive substances such as uranium, but there is also another possibility of fusion that is the ultimate source for us, that is the sun's energy is being driven by the nuclear fuel as well, right? So keep that in mind. So these are the forms of energy. Let's do a couple of questions now very quickly to apply what we have understood so far. Majorly we have talked about only two mathematical expressions here. One is for kinetic energy, that is half mv square, and the other is potential energy, that is mgh. All right. So a bullet of mass 0.02 kilogram travels at a speed of 1500 meter per second. Calculate its kinetic energy. So I think without wasting any time, let's apply the formula half mv square. Even though very light, still a bullet has a huge amount of kinetic energy thanks to this high speed that it is possessing, right? So half times 0.02 times 1500 whole square. So this will give us half times 0.02 into 225 into 10 raised to the power 4, isn't it? So let's do the calculation quickly. So this is going to be 225, this is going to be 0.01, so this is going to be 10 raised to the power 2, right? So this is giving us 22.5 into 10 raised to the power or we can write it as, let's say, 22.5 into 10 raised to the power 3 joule. Why? Purposely to use the prefix kilo. So I can write this as 22.5 kilojoule, right? Easy, no big deal here. You just have to apply the formula kinetic energy is equals to half mv square. You should be able to do that. All right, the next one, a package of 5 kilogram is lifted vertically through a distance of 15 meter at a constant speed, taking the acceleration due to gravity to be 10. So we are taking it as 10. Calculate the gravitational potential energy gained by the package. So just now we have written the formula of potential energy, that is mgh. So the mass of the package is 5 kilogram. Wouldn't it take some effort to pick this up? Of course, yes. Whoever the crane is or whatever the thing that is lifting is spending its energy, and that is being converted to potential energy. Okay, so now mass is 5. So one thing before that, at a constant speed. So what is the word written here? Constant speed. So the crane or whatever the agency is lifting the block, it's not changing the kinetic energy of the package because it is being lifted at a constant speed. The only energy that this is providing is the potential energy. Kinetic energy is not changing, it's not gaining that energy. So keep that in mind. Though they only are asking us to calculate the gravitational potential energy, G has to be taken as 10 and H is like 15. So 5 times 15 is going to be 75 and this is 10. So the answer is going to be 750 joule. 750 joule. Shouldn't be a problem, right? Still copy down and then we move forward. So the last question that I wish to take in this particular class. So today was just an introductory class of this. Next we will talk about the energy transfers and then we will discuss in detail what is work, what is power and all those things, right? So an astronaut on the moon has a mass including his spacesuit and equipment of 175 kilograms. That's quite heavy. The acceleration due to gravity on the moon's surface is 1.6 as we already know. Calculate the astronaut's weight on the moon. Alright, so let's do this calculation very quickly. So we do know that weight is equal to mg. So m is like 175 and gravity is like 1.6. So let's do that. 175 times 1.6, that is 280 Newton, 280 Newton. Then the astronaut climbs 100 meters to the top of a crater. All right, that's quite. By how much does his gravitational potential energy change? So he's climbing, he's gaining potential energy, and what is the amount? The answer is going to be mgh. So mg we have already calculated 280 and h is like 100 meter. So this is going to be 28,000 joule. You can write as 28 kilojoule. Does his GPE increase or decrease? Without a doubt, he's climbing, so it is increasing. If he will, go, down in the downward direction, then his GPE will decrease. So it was just a basic class today, but then we had to do this to understand topics further, and I hope you should be able to understand everything that I talked about in one go. And now we will come up with another theory class of this, and maybe then we will start with the PYQs. Then you would understand why exactly we did things in this particular fashion. But yes, when we do the PYQs, needless to say, they are always multi-conceptual. So they would include the concepts of motion and force. So before you join those particular classes, it's always advisable to revise everything that we have done so far. But that's all for this particular class. I hope you were able to understand and enjoy the class. That's all. I will see you in the next one. Bye bye. If you enjoyed this video, please don't forget to like, share and subscribe to our channel.